All right, so we had problem number 6 of lesson 4 homework, and that says let W be an arbitrary vector x, y, y, and let that be over the set of, or let that be where x and y are elements of the real numbers. Now, if you look at the arbitrary value, you know that the first value of x is the difference between the second value of y. So it's going to be x minus y, y. Now, the first part of the problem is W a closed subset of R3 over addition? So whenever we have to, I guess, figure this out, we have to do the criteria first. So one, is the operation binary? So we're talking about addition here. Well, yes, it is, because addition is going to be binary across all the real numbers, 2 or 3. And the second criteria is W a subset of the universal set? And that's also the parent set of R3 over addition. So if W is the set of all real numbers, which is going to be considered in the subset of R3, now we need to prove that the two arbitrary vectors, when added, yield an arbitrary vector within the subset of W. So now I'm going to hand it off to Zach, where he's going to explain the proof.
So, as Noah said, we need to find two arbitrary vectors that when we add them together are going to yield some arbitrary vector that is in fact a subset of W. So right here we're going to start with the arbitrary vector of A minus B, B, and we're going to add that with the arbitrary vector x minus y, y, and we're going to want both of them to be subsets of W. And we want them to yield some vector, let this arbitrary vector be C minus D, D, and that also needs to be a subset of W. So first we're going to say let a vector U be our first arbitrary vector of that A minus B, B, and we'll let some other vector V be our second arbitrary vector of x minus y, y. And we're going to claim that U, or vector U, plus vector V is an element of R3. So if they are both an element of R3, then they should yield a vector in the form of C minus D, D. So then when we add these two vectors, they're going to give us A plus x, A minus B plus x minus y, and then B plus y. Now, we can look at this inner part, because if we kind of look back to the form that we're wanting to get it in, it's really we're getting a first value, a second value, and we're going to have the middle value is going to be the first minus the second. So that's kind of the form that we're wanting to get this longer of the two vectors added together in. So when we take the A minus B plus x minus y, we can rewrite it as A plus x minus B plus y, and this is the first minus the second. A plus x, B plus y, A plus x, B plus y. So that is in the form of C minus D, D. So vector U plus vector V is a subset of W, thus it is a closed subset under addition, because we found both of those to be a subset of W, and we wanted to find that in a subset of W. So Noah's going to carry us through to our last part.
All right, so now our second part of the problem is to, if we got through this, determine the span of W in R3 over addition. So because we know that it is a subset under addition, we'll be able to determine span W, and it's actually very easy, because since it is a subset, by definition of span, the span of the closed subset is itself. So span of W is W. You're not going to have to add anything to it to make it closed, because it's already closed. So just like that, the problem's done.